Guys, so today's video is about P115A and P115B. You can probably tell this by the title of the video already. But before I proceed and discuss these codes, I would like you to have a look at my instrument cluster and see what's the difference between this cluster and some other clusters. I'll give you guys a hint. There is a light in this cluster that's missing. Have another look. Were you able to find any difference? All right. So this time I would like you to look for the low fuel light. There is no low fuel light on this cluster. And this is the reason we have P115A and P115B. This is a diesel variant of Ford Territory. So I'm not sure about the petrol version, but in the diesel versions, it is, in fact, in all the diesel cars, it's really important that the car does not run on empty if the injector, especially the high pressure fuel pump, so the high pressure fuel pump is lubricated by the diesel fuel itself. So if the car runs on empty, then this means the high pressure fuel pump can run without lubrication for a while. Same goes with the injectors. The high pressure fuel pump, when it runs dry, it sheds off the metal shavings that go into the injectors, and the whole fuel delivery system is impacted, and the repair cost is huge. It's phenomenal. I mean, if you just look at the high pressure fuel pump cost, it's around 2 to 3 grand. So what the engineers did in this car was that the low fuel switch that's back there in the fuel tank, they connected it directly to the PCM in here. So whenever the PCM gets a low fuel signal, it limits the power of the engine by limiting the fuel that gets delivered to the engine. So this is called the run dry protection system. There are advantages of run dry protection system, as I discussed, prevents the car. So what it does is that whenever it detects a closed loop at the back and the switch is closed because the fuel is really low, it's a magnetic switch at the back in the fuel pump. So when the PCM detects a short circuit or a closed switch, it knows that if it's running on empty, so what it'll do is that it'll trigger P115 into the, and probably a check engine light. In some cases you don't get a check engine light, you just get a P115 code. And with that, and you will not see it, but you will feel the symptoms. And the symptoms are that the car will start to choke when you try to accelerate. It starts jerking and shuddering, and that's the initial symptom. So if you continue running like this, after a while, the PCM will stop the engine. It will no longer provide any fuel to the system to prevent the car from running on dry. Even though if there's some fuel at the back, now there's another problem where if there's still fuel in the car, it's quarter tank, half a tank, but for some reason the magnetic switch closes, especially in the mornings when it's cold, the switch at the back closes, and the car runs shudders for a couple of minutes and then stops if you continue driving. But if you just stop at the stop on a street and then just restart it, it will be all good for the rest of the day. But every morning is the same story, especially with this car. In extreme cases, what happens is that if that is permanently shut, the PCM will say, oh, there is no fuel in the car. It will not look at the fuel level for some reason. That's where the stupidity of this whole design comes in. It just looks at that switch, value of the switch. If it's closed, for PCM, there is no fuel in the car. So even if the tank is full and that thing is switched, the thing is closed internally, the PCM will not let the car run. In extreme cases, you cannot start the car. So after having this trouble for a while, what I decided was to bypass this system in a way that I want to retain its advantages and not advantages, in a way that it does not impact the functioning of the car, but it does not also leave me stranded somewhere by reducing the reliability. So I just don't want to have it. So some people, what they do is that they just cut off a couple of wires, or just one wire. So there's one wire, 5-volt wire, that goes to the back towards the switch, and then there's a wire that comes back to the PCM. So the wire that comes back, it's a ground. The PCM provides it to the ground, and then it measures the current draw on the ground. If it detects any, it will know that the wire at the back is the connector at the back is short. So what people usually do is that they just cut off the 5-volt supply wire or the earth wire. Any one of them, you cut one of them, you'll be fine. But the problem with that approach is that uh, uh, if you run empty and you do not have a habit of looking at the fuel cluster inside the fuel cluster, you have on the fuel gauge inside the cluster, just like me, if you don't have the habit of looking at it occasionally, then you may run empty, and this is where the problem will be, because there is no light at the cluster that tells you that you're low on fuel, and the PCM has no way of knowing that you're running low on fuel because you've cut the wires. So what I'm trying to do here is to introduce an additional light in the cluster, and then I'll use the car wiring to give me a light when it's running low on fuel, but do not tell the PCM that it's running low on fuel. Otherwise, in extreme cases, it can let me prevent from even starting the car. So I'll show you what I'm trying to do. So we have this fuel pump diagram over here. We can see that the low fuel switch, it connects to the PCM via these two wires. One of them is a 5-volt supply wire, and the other one is a ground. It is a controlled ground, which means that the PCM gives the ground, provides the ground to this wire. So this wire says it's SR. So if you go to the color code, it says S is for gray and R is for red. So we should be looking for a wire that is gray red, and it terminates at number 8 of connector A. So the theory is, if we disconnect it from here or unplug it from here, this connection will never be complete, and PCM will never know that it's low on fuel. So this is what I plan to do. We have, as we looked at the wiring diagram, that we have two wires going all the way to the fuel center and then coming back. So one is this blue yellow wire. This carries the voltage, it takes it to the switch, and then the other wire, it actually carries it back to the PCM and grounds it. So the one that carries the voltage is blue yellow, the one that grounds it is the gray red one. So my plan is to cut out the gray red wire somewhere in the wiring, and then I'll take one wire off of it. I have a green and a yellow wire that I'm going to use in this demonstration. So I'll put a green jumper from here on the gray red and take it all the way back to the instrument cluster, where I'm going to put a LED light in. So this is just a symbol for the LED. This is just a symbol for the bulb, whichever you want to use. So that resistor, if it's a 5-volt supply, you are going to use around 150 ohm. If it's a 12-volt supply, you're going to use it around 450 ohm. So since this is an LED, since this is a diode essentially, to just make sure that you attach the positive end of it here, not the negative one, otherwise it won't work. And in the end, when you have laid down the wiring and start working, and you are not sure which way is positive, which is negative, just flip it and you'll know what it is. And then I'll ground the negative end to the chassis. This way the circuit will complete whenever there is a low fuel condition, and it will show and the light will come on. Also, before concluding, what I'll do is I'll just put a jumper between the wire here and here, just to simulate a closed circuit and see if my light comes up. If my light comes up, then it means that my circuit is working and I don't need to worry about it. Each and everything is working. And after that, I'll just remove this jumper. So let's see how it goes. The wiring that goes from the PCM to the fuel pump actually comes from the left side. So it enters through the firewall into here, the left side, and the wiring is located behind this this plastic piece. To remove this, you have to remove this territory plastic piece first, and then there are a couple of screws, one over here and one over here. You have to remove them and this thing will lift up, and all you need to do is just pull it out just like any other normal piece. So this will expose the wiring that you need to look for. I've tracked down the wires further and I realized that once they go into this connector, come at the back of it, and then it makes a loop and goes back in again, and then I realized it come from here. So they're right in front of me. They were here right in front of me the whole time. So that's the one that we need to cut. That's the gray with the red with the red line, and that's the one that's 5-volt supply. That's blue with the yellow line. So what we'll do is that we'll test this wire, and the way we are going to test this I'll show you before we cut it, and just to make sure that we're not cutting the wrong line, I'll show you how we do it. To make sure that I'm cutting the right wire, here's my setup. So this is the connector A, and I have put in this safety pin in A8. So if you compare it with the diagram that I've shown, this is exactly where I've put it. And then this one is on currently I've disconnected it. This one is on auto, and on here I've connected the other end to this gray red wire. It's slightly chipped a bit of the wire, and now let's see. So I have a direct continuity, so which means that I'm tracing the right wire. See, it will not chirp with anything else. It will just beep with the only wire that I know where it is. So that's the one. So now I know that I'm looking at the correct wire. That's the ground path. The plan is simple. I'm gonna put this 5mm LED in front of the cluster, right in front of the fuel gauge. I'll drill a hole in it and I'll put it in. This is I just bought it off JCar. It has a forward voltage drop of 2.3 volts, and since the PCM provides a 5-volt supply, I'm gonna need this 150 ohm resistor. I'll solder a 150 ohm resistor in series with this LED and connect it in the return path of the wire coming back from the fuel sensor, fuel switch. So once I have it ready, then I'll lay down a cable between where I'm trying to introduce this in the circuit and back to the cluster. So I'll show you how it looks like. My final setup, so resistor in series with that of an LED, and at the other end I have a connector. I connect it to this green wire now, which I've pre-terminated, and I'm gonna tape it off with some electrical tape so that these two doesn't get in contact with each other. We'll start by lowering the steering first. Lock it at the minimum position. Then we'll have to pull this thing up. I've already removed it, and the back piece is the rubber one that goes into these slots. So just pull it up and then pull it back. It should come out. Now this leaves us with the next slot here. So just pull it out. There are only two tabs, right and left. One out there and one over here. And now this exposes two screws. One screw is over here and one on the other end here. So we have to remove these two screws and then pull this thing out. After taking the instrument cluster out, removing these two screws, I just have to pull this thing out. When I pulled it, these are the two connectors at the back. Just have to remove them and this thing came out. Now what I'll do is that I'll try to put an LED somewhere over here right in front of the fuel gauge, so that I know where it's coming from, or the person who's driving, but it's not me, knows that this has something to do with the fuel gauge. My setup almost complete. There is an LED over there that I installed. It's a yellow one similar to all the warning LEDs, and it's right in front of the fuel guard, so I should have an idea when this one glows up finally. So this LED, since again it's a diode, so it has a positive end and a negative end. So there are two wires connected at the base of the LED and also there is a resistor in series with one of these terminals. So the positive end of the LED is connected to the green wire and the negative end is connected to the blue wire. So I brought these wires down. The blue wire is then I found a good grounding connection and grounded it directly to the chassis. The green wire that goes all the way to the other end, and it connects to the wire that goes to the back. So there are two things that came as a surprise to me. The first thing is that whenever I try to start it, you can see that the LED for the fuel is still blinking. It should be blinking, and if I switch it off, it will run for a while, and it will run for the same time for which the electronics of the car is allowed by the PCM to run. So it looks like there is some voltage in the circuit residual, and from the wiring diagram I cannot figure out where this voltage is coming from. The second issue that I see here is that instead of 5 volts I'm getting around 11 volts, 12 volts. So it seems like I think that the voltage supplied by PCM is either variable or it's 12 volts, it's not 5 volts for sure. So one thing that I need to do is to jack up my resistance in series so that the voltage drop can match the safety voltage of LED, otherwise the LED will blow up. So to demonstrate that now this thing is working, I'll put a jumper between the voltage and the circuit that we just installed. So first have a look at the LED. So you can see that the LED is not working. So I'll put a jumper between the voltage and the LED circuit. That should close the loop. And now we can see that our LED is working. So this thing is working fine, and it should hold up when the fuel is low.